Hi, this video is to demonstrate how to operate a Model 80 DH-Budenberg deadweight tester, a pipeline deadweight tester. Only this one has been configured without a mechanical pressure gauge for indicating pressure loss in a pipeline, but instead with a crystal digital pressure indicator which will attempt to do the same thing, but without some of the problems that could possibly come from a mechanical gauge being overpressed and being offset from zero through shipment and the like. So in this setup we have the DH-Budenberg Model 80 deadweight tester set up with a pipeline pressure being simulated by another deadweight tester externally, and that pipeline pressure is being indicated here by the use of a digital pressure gauge, and we're supplying about 31,000 kPa for this exercise. This digital pressure indicator then is operated and is connected in circuit to some tubing which is connected to the auxiliary bearing on the piston cylinder unit. There is a reservoir of oil here. That circuit can be closed off by closing the reservoir valve, and pressure can be then applied to the auxiliary circuit using a screw press. The operation of this gauge is done by, once the operator has turned the gauge on and with this reservoir valve open and vented, zero is pressed and a preset zero offset of 1000 kPa is then displayed on the gauge. To take a reading, currently we have 30,000 kPa of masses loaded on top of the piston and its adapter. I would tend to put on between 250 kPa to 750 kPa of mass. In this case I'll put on an extra 500 kPa of mass, which will drop the piston to the top of the blue band. We will then close the reservoir valve and apply some pressure to the circuit to refloat the piston into the middle of the red band, and after letting some readings stabilise, we can see we have a pipeline pressure equal to the 30,500 kPa of masses loaded onto it, plus the gauge reading of 500 kPa, which is 31,000 kPa, which is near to what our line pressure is. Now, if we were at a later time to take a reading as if the pipeline had lost 400 kPa of pressure, I can simulate this by removing 400 kPa from the pipeline pressure, and I would then refloat my piston to the red band and let some readings stabilise again, and we can see we've now got a reading of 100 kPa on the gauge, showing a loss of 400 kPa from the reading we previously had at 500. So this gauge is perhaps a little more capable of withstanding some overpressure, so if we happen to go too far in pressure and go into a negative area, the pressures could be applied to minus 1000 kPa, potentially without taking any damage to the instrument. This could cope with a lot more pressure than that. Once the reading has been taken from the gauge, it is recommended that the valve on the reservoir be opened, so that any pressures are not going to be applied into the auxiliary circuit, causing any potential damage to tubing or the gauge that's in the circuit, until and then those things can be reset for the next time a reading needs to be taken. So we hope in that video to have shown that the operation of the crystal digital tester gauge in this circuit is simple and easy to operate. We find that the volume you need to wind in with the screw press is much smaller than that you would use with a mechanical pressure gauge, which makes it easier to operate. But it also makes it much more robust, because this instrument is much less vulnerable to any damage from being overpressed, which is a common complaint and a problem in the industry, or zero shifting of the gauge through the gauge having been transported. We think that the accuracy of this gauge in use is within about tolerance of plus or minus 3.5 kPa, which should offer more accuracy for operation than the previous mechanical pressure gauge. particularly with the ability to zero before use, which is a relevant offset concern for other operations with the mechanical gauge. So with perhaps with some temperature measurement of the piston cylinder unit in use, combined with the use of this gauge, it provides a very simple means of measuring pipeline pressure simply, perhaps without the complication of using small trim masses if you were to use a deadweight tester without the use of this gauge on the auxiliary bearing circuit. The battery life is long, for lasting at least 1500 hours, which is a long time to operate. Batteries are able to be changed easily from a pouch at the back without having to access the back of the gauge. So I hope that's been of some use and is interesting to you. Thank you.